What are the prime integral factors for 4x squared minus 81? I have a binomial. I have subtraction. I have an x to the second power. So I'm going to see if I can get this to be the difference of two squares, a squared minus b squared. So a squared minus b squared. If I make a 2x and b 9, then this is the same thing as 2x squared minus 9 squared. 2x squared gives me 4x squared, and 9 squared gives me 81. So now I can rewrite this as a minus b, a plus b. So it will be 2x minus 9, 2x plus 9. So my answer for this one is going to be B. Because it is multiplication, it doesn't matter which one is first, the 2x minus 9 or the 2x plus 9. For 2, find the area of the parallelogram. Area is equal to base times height. The base for this is 6a plus 7b. Times the height, which is 6a minus 7b. And the units for both is centimeters, centimeters. So we know our answer is going to be centimeters squared. So if I look at the two binomials, I have plus 6a plus 7b, 6a minus 7b. This is the difference of two squares again. So my answer is going to be 36a squared minus 49b squared. But some of you need to see that this is going to work out that way. So we have 6a times 6a, which gives me 36a squared. Then we have 6a times negative 7b, which gives me negative 42b. Then we also have 7b times 6a, which gives me positive 42b. And then we're going to do the last terms here, which is 7b times negative 7b, which will give me negative 49b squared. So the middle terms, as you can see, if I do negative 42b plus 42b, that goes to 0, and my final answer is 36a squared minus 49b squared. What is the factored form of x squared minus 36z squared? Again, I have a binomial, I have subtraction, and I have to the second power. So I'm going to see if I can put this in a squared minus b squared form, which is the difference of squares. So a squared minus b squared, if I make a equals x and make b 6z, then I have x to the second power minus 6z to the second power, which gives me x squared minus 36z squared. So now I can write this in the form of a plus b, a minus b. So I'm going to get x minus 6z times x plus 6z. So my answer for 3 is going to be A. Again, it doesn't matter because it's multiplication, which one comes first. So A is the answer for 3. For 4, when completely factored, 2x squared plus 2x minus 24 is equivalent to what? I see that there is a common factor of 2 in each one, so I'm going to divide the whole thing by 2, and I'm going to have 2 on the outside, which gives me x squared plus x minus 12. Now I'm going to factor the trinomial. Okay, so this is where I'm going to do the product sum method. So the product, I want two numbers that multiply together to give me negative 12. But I also want the same two numbers to add to give me positive 1. So what two numbers multiply together to give me negative 12, but also give me positive 1? Well, the factors of 12, you have 1 and 12, of course, 2 and 6, 3 and 4. The difference of 3 and 4 will give me 1, so it's probably going to be 3 and 4. If I make 4 positive and 3 negative, I get negative 12. But if I add positive 4 and negative 3, I will get positive 1. So this is going to become x minus 3 and x plus 4 times 2. So my answer is going to be C. For 5, which of the following are true statements? Mark all that are true. Well, if you look at B and D, they're saying the same thing, x squared minus y squared. So we just learned, we didn't just learn, but the difference of squares is written as x plus y and x minus y. So I know B is definitely out. And D is true. Now for A and C, I'm going to multiply that out, x minus y and x minus y, to see what I'm going to get. So if I do x times x, I get x squared. And then x times negative y gives me negative xy. Negative y times x gives me negative xy, and if I do the last term, negative y times negative y, which will give me positive y squared. If I simplify this, I get x squared minus 2xy plus y squared. And that is not equal to what is on the left, so that one's not going to work as well. For C, I have x plus y and x plus y again. So I'm going to multiply that out. X times x gives me x squared. And then x times y gives me positive xy. Take y and distribute it through the parentheses. Y times x gives me plus xy again. And then y times y. Y times y will give me plus y squared. If I simplify this one, I get x squared plus 2xy plus y squared. Again, this does not equal what is on the left here, so that one is not the answer as well. So my answer is going to be D for number 5. 6. 1 factor of 5x squared plus 13x minus 6. For this, I'm going to do a combination of methods. I'm going to do the product sum method with grouping. So first thing I'm going to do is I'm going to multiply 5 times negative 6. So product that I want is going to be 5 times negative 6, which is going to be negative 30. And then the sum that I want is going to be positive 13. So I want two numbers that multiply to give me negative 30, but add to give me positive 13. So two numbers multiply to give me negative 30, but they add to give me positive 13. They have to be the same number. So I have the factors of 30, 1 and 30, no, 2 and 15. Yes, we want the difference of 2 and 15 will give me 13. So let's see, 15 and 2, 15 and 2. We know one has to be positive or negative, but we want to make sure that when we add them, we get a positive 13. So if I make negative 2 negative, then I will get positive 13. Now, the third thing that I'm going to add to this is grouping. So I'm going to rewrite this as 5x squared plus 15x minus 2x minus 6. Now I'm going to group these according to a common factor. So for the first set, I'm going to factor out a 5x, and I'm going to get x plus 3. And then the second set, I'm going to factor out a negative 2, and I'm going to get x plus 3 again. And I notice that they now have a common factor of x plus 3, which will become 5x minus 2 times x plus 3. So one of the factors will be 5x minus 2.